All right, page 4 of the study guide. In questions 36 and 7, we are finding the distance between 2 points. Remember, we do have a distance formula, but I'm just going to use the Pythagorean theorem. They are essentially the same. So in 36, what I would do is I would turn this into a right triangle, and I would just think of this as a triangle now. So this side length, or this leg rather, is 1, 2, 3, 4, 5, 6 units. This leg is 1, 2, 3, 4, 5, 6, 7 units. So if I want to find the length of the hypotenuse, essentially, I'm going to call that my distance. I'm going to label it D for distance. I'm going to do 6 squared plus 7 squared equals D squared, because we're going back to our Pythagorean theorem of A squared plus B squared equals C squared. All right, so 6 squared is 36, 7 squared, 49, equals D squared. When I add those together, 36 plus 49 is 85. All right, so we get 85 equals D squared. We really need to take the square root. We just have a little quadratic here. The square root of 85 is going to be D. And we want to check, like, can we simplify that radical? Well, 85 doesn't have any factors that are perfect squares, so we can't. But we can approximate it. If you actually use your calculator to take the square root, we'll take it out to 3 decimal places, 9.2195 rounds to 9.220, and that's our approximation. All right, so you need a calculator. I will accept the square root of 85 as well. All right, in question 37, we're doing it without a picture. If you were like me, I draw a picture. That's really helpful. But we could also just find the differences in our x's and the differences in our y's to get our triangle. So if I think about it, my x values are changing from +2 to -1. So this part of my triangle is going to be 3 units. My y values are changing from -9 to +4. So that's going to be a change of 13 units. If I started at, let's say this is at -9, and I go all the way up to +4, that should be 13 units. Now, I often will just sketch a graph like the one over here. It's very helpful. All right, so we're doing the same thing, Pythagorean theorem. So 3 squared plus 13 squared will give us the length of our hypotenuse, which is our distance squared. 3 squared is 9, 13 squared is 169, so that'll be D squared. When I add 169 plus 9, it's 178, and I take the square root. So basically just like the last question, the only difference here is that you weren't given a graph. So our distance is approximately 13.342 units. All right, the rest of these should go much faster. Those two are lengthy problems. In 30 through 41, we're using this diagram. So name 2 parallel planes. So if I think of this as a box, if I think of these rectangles continuing indefinitely, I want to pick 2 that won't intersect. So the top and the bottom will intersect, but I guess we could actually name the bottom ABG and just realize we don't really have a name for the other point over here. But instead of doing that, I'm just going to pick, actually, can I do that? Yeah, I can, sorry, I take it back. It doesn't really matter which 2 we use because there's more than 2 sets of parallel planes. So if we wanted to say that the top is parallel to the bottom, let's say I call the top DFE. So the top is DFE, and it's parallel to plane ABG. We could also use this side and say that like BCG, that plane is parallel to ADF. So there's several possibilities. You could also do the front plane and the back plane. All right, in number 39, name a segment skew to segment BG. So segment BG is on this line right here that uses point D. So we said skew lines are not parallel, but they also don't intersect because they're in different planes. So BG is going that way. DA is the one that stands out to me. But we could also use DC because DC would also be skewed to BG. So neither of these are on either of the planes that segment BG is on. So I'm going to use DA. Number 40, name the other points coplanar to C, D, and E. So if I look, C, D, and E are all on this top plane. F is the only other point that's on that plane with them. Number 41, name a segment parallel to BG. So we have two possibilities here. We could say segment CE, so I might say CE. We could also say DF, and it might not appear because we said parallel lines have to be in the same plane, but if we were to cut this, like if you took a knife and cut through this diagonally, these are on a plane that exists in here. So like these are on that plane. So they are still parallel lines because they're still on the same plane, or parallel line segments. All right, 42 through 45, we are almost done. Using this diagram, name an angle vertical to angle TOM. So remember, vertical angles are made by intersecting lines. So this line and this line, we're gonna get this big angle. So NOS. Or SON. A linear pair to NOM that uses point T. Point T is down here, so if I use this angle, its linear pair has to be this angle so that they make this line that's right here. So TOM or MOT. Let's see, I think I left off the first part of this. Oh, name an angle that is complementary to angle NOP. So if this is angle NOP, complementary means when we add them, we get a right angle, and I can see that this is a right angle right here. So NOP, I would have to add angle POR. And of course, you could call that ROP. All right, 45, we are just gonna go in and find the measures of the angles. I recommend filling out the diagram first and then answering those questions. So if this is 33 degrees, this angle has to be 90 minus 33 since they're complementary. So 90 minus 33, is 57. So this would be 57 degrees. And then because these two angles are complementary, this has to be 33 again, so they add up to 90. So then we know that this angle, that all of these have to add up to 180. Or another way of thinking of it is that like if this is 90 degrees, this is 90 degrees. So this is also another 57 degree angle. Then we have our vertical angles, so that is 57. And then lastly, this linear pair. So if I subtract 57 from 180, I get 123. All right, now I'm gonna fill these out. The measure of POR, let's see, POR is 57 degrees. The measure of ROT, that's a 33 plus a 57, so that's 90 degrees. NOP is a 33 degrees. MOT, we identified that as having a measure of 123 degrees. The measure of angle NOM is 57, 57 degrees. And lastly, angle TOP. So for T to O to P, I have to add these up. So that's really like a 90 plus another 57. So 147 degrees. That's it.